Hello everyone. In this session, I'm giving one more example for the construction of the LL1 parsing table. So consider a grammar. Here I have taken the three productions. S is deriving two productions and A is deriving epsilon and B is deriving the epsilon. As a procedure, first I have to check whether the grammar is consisting of left recursion or not. So here S is deriving some other non-terminal. So S is deriving some non-terminal A and here some other non-terminal B. So it is not consisting of any left recursion. The grammar is ready to apply the LL1 parsing table. So the first point is removal of left recursion. This grammar doesn't need left recursion. And the second point is finding out the left factoring. So here we have AB and BA. No common prefixes are there in between these two productions, and here also no common productions are there in A and B. So it is already free from the left factoring. So we have checked the 2 points, and coming to the third one, we have to calculate the first and follow functions. So first we'll start with the first function. Calculating the first function of S. First of A. First of A is, it is deriving, first of S is deriving the non-terminal A. So non-terminal A is having the epsilon. So in the case of, so we have to consider first of A, and if first of A is consisting epsilon minus epsilon, then union first of A, B. We have to consider the remaining all production. So now first of A is having the epsilon, so that epsilon, and we are minusing the epsilon comma. Now first of A, so in the place of A, if I am going to be replacing epsilon here, then what will the first of S will come? The first of S will come, the terminal A. So I'll consider A. So here epsilon is there, so that we are minusing the A. So we will take A as the first function, and one more production is there for S, that is B. So first of S will also become first of B. So again I am going to be considering B also. Again B is also having the epsilon, so that minus epsilon union. What are the remaining part here? BA. So if here after B, if it is a terminal, then directly we can take the terminal. If it is a non-terminal and that non-terminal is also having the epsilon, again we have to consider the second terminal or non-terminal. For because of that reason, we are writing the remaining production as total remaining production here. So first of B is epsilon. So epsilon minus epsilon will be removed. Union first of B. First of B here is the terminal. So directly we can consider the terminal, and we need not considering it. Suppose again here it is a B. Again if it is a B, again B is having the epsilon, so that we will consider the first of B. Again the second one, the remaining production we have to consider. So that reason I'm going to be writing the entire production here. So the first of S will become A comma B. Next, first of A will become only epsilon, and first of B also will become only the epsilon. These are the first functions. So just we will write here for understanding first function and the follow function. Let's make this as table. So we have S, A, B, and first function or A comma B, and A is epsilon and B is also epsilon. Now we will calculate the follow function of all these non-terminals. Coming to the follow function, as S is the initial state, so that first I am going to be finding out the follow function of S. You can observe S is not at all available at the RHS side of a given grammar. Here no S is present at the RHS side. No S is present at the RHS side, so that only dollar will be considered as the follow function of S. Next, follow function of A. Follow function of A. Where is A? Here is A. Immediate to the A, what is available? A terminal A is there. So first of A, we have to consider the first of A. So first of A is having the epsilon. So in such cases, what it has to do? First of A minus epsilon union. After A, what it is there? A is there. Again, it has to consider the first of A. First of A. Oh, sorry. Here A is the terminal, right? Here A is the terminal. So first of A is nothing but A only. First of any terminal will becomes the same value. So that first of A will become A only. Next, follow function of B. Follow function of B. So follow function of B is nothing but where B is actually present. B is actually present here. So immediate right to the B, what is there? Immediate right to the B, here terminal B is there. Terminal B is there. So we have to consider first of B. First of B will become B. Here you have to observe, here A is there, again here also A is there. In the last session, I have given one example where one non-terminal present at any side, it is going to be having the same values. But in this grammar, you can observe this follow function of A and this follow function of B will get the different value. So that we have to consider both. So here, follow function of A will become first of A. Follow function of this second A will also become the first of B. So that we have to consider both. So here I will get the comma B and here I will get the B comma A. Why? Because for the follow function of B, this B will come. And the second B is also following with some another terminal. So that we have to consider the A. So here we have only the dollar and here we have A comma B and here we have B comma A. B comma A. So these are the first and follow functions. Now we are constructing the LL1 parsing table. So at the row side, LHS side, we have to write the all non-terminals what we have. These are the non-terminals we have. And here we have to write the terminals. Terminals we have A, B, only A and B. Epsilon we won't consider. Instead of epsilon, we will write the dollar. We will write the dollar. Right? So now we are going to be writing LL1 parsing table. So here first we will check for S. First production, S derives AA, AB. So S derives AA, AB is nothing but it can write in the A comma B. In the A comma B. So S derives AA, AB. It starts with AA, AB, so that we have written under the under this one. And here we have to write the S derives BB, BA. And first function of A is having the epsilon. So that if the epsilon is there, then we have to write it in the epsilon is there, then we have to consider the follow function of A. Follow function of A is having the A comma B. So under A we have to write the A derives epsilon and A derives epsilon. and first of b is having the epsilon, so that we will consider the follow of b function. So the follow of b is having the b comma a. So here also we have to write b derives epsilon and b derives epsilon. So this is how we have to construct the LL1 or predictive parsing table for the given grammar. Thank you.